Welcome to the Jamb Master 30 Days Challenge for Physics Day 1. You're all welcome. You're all welcome. The Jamb Master 30 Days Challenge for Physics Day 1. Welcome. Please, as soon as you come in, let me know if you can hear me. Let me know if you can hear me and let me know if you can see the board. As soon as you come in, please notify your presence. Notify your presence. You are all welcome. You're all welcome. You're all welcome. You can see the topics we are treating today already on the board, right? These are the topics we are treating today on the board already. So start writing down. Get rid of all distractions. By now, all our students don't have TikTok again, right? No Jamb Master student has TikTok on their phone now. There is no Jamb Master student that has TikTok on their phone. We deleted our TikTok yesterday. We deleted our TikTok yesterday. There is no Jamb Master student that has TikTok on their phone. If you can hear me clearly, say, sir, we can hear you, sir. If you can see the board, say, sir, we can see the board. Welcome, welcome, welcome. If you can hear me, say, we can hear you, sir. If you can see the board, say, sir, we can see the board. The Jamb Master Life Chemistry class, day one. I'm just about sending the link, then we start. Welcome, welcome, welcome. Welcome, welcome, welcome. Welcome, welcome, welcome. If you can hear me, say, I can hear you, sir. If you can see the board, say, we can see the board, sir. If you can hear me, say, we can hear you, sir. If you can see the board, say, we can see the board, sir. Welcome, 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 welcome. Welcome, welcome. Get rid of all distractions. Get rid of all distractions. Get rid of all distractions. Welcome, 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 welcome. Get rid of all distractions. Get rid of all distractions. Welcome, 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 welcome. If you can hear me, sir, I can hear you, sir. Yes, I'm seeing Timileyin Victor. Yes, the first person to comment today, Timileyin Victor. Yes, 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 yes. Welcome, welcome, welcome. Yes, yes, yes. Yes, there's no time to waste. We get the ball rolling immediately. I want to start today with some ups. Yes, let us make our commitment. I will not live to the end. I will not live to the end. Type in the comment section, I will not live to the end. Commitment for today, I will not live to the end. Let's go. Let's start with some odd questions on motion quickly. A body moving with a velocity of 50 meters per second is brought to rest in 30 seconds by a constant retarding force. By a constant retarding force. A body moving with a velocity of 50 meters per second is brought to rest in 30 seconds by a constant retarding force. Calculate the distance covered by the body. Another question. A car moving with a speed of 144 kilometers per hour. Slows down with a uniform retardation of magnitude 10 meters per second. How far will it travel before it comes to rest? Another question. A body starts from rest so we have question 1, question 2, and question 3. A body starts from rest and accelerates uniformly at 5 meters per second square. Calculates the time taken to cover 1 kilometer distance. Class, we're opening today's Marathon Physics Day 1 with 3 odd motion questions. Our first topic today is Newton's laws of motion. It's only right that we open the floor with some motion questions. If you can hear me, say you can hear you, sir. If you can see the board clearly, say you can see the board. Let me drop the number in case there's a general network breakdown. I'll drop a phone number that everybody should call and say, sir, please, can you end the live and start again? We are all not seeing you or it's getting blurred. Are we together? So emergency contact. Call me on this line as soon as, not one person should call me, please. Confirm that it is a general problem before you call me. 09039206950. Confirm there is a general problem before you call me. Confirm that it's a general problem before you call me. If you are the only one not saying, please don't call me so you don't stop the live. So if everybody is not saying, means that my network has gone down, you just inform me. I will then do what? End this live and then start another live and send the link. You are all welcome. You are all welcome. Have you taken down the question? Yes. People are saying, I will not live to the end. That's the energy. People are saying, I will not live to the end. I will not live to the end. That's the energy. That's the energy. That's the energy. I will not live to the end. I will not live to the end. That's the energy. Quickly write down the 3 questions so that we can proceed. I'm giving you small time to write down the 3 questions so that we can proceed. Please also take note that some topics have been done before this day 1. If you're just joining, I will send all the videos on physics that has held before this day 1. So that tomorrow during the daytime, you can take time and watch them and catch up. I'll send all possible videos on physics that we have done so far. I think we have gone live like up to 3 times on physics before this day 1. We have gone live like 3 times. And I think there are 1 or 2 or 3 more videos. I'm going to send them to you because those topics will not be treated again so that we can save time. Are we together? Topics like projectile motion, circular motion. Are we together? We've taught some topics. Yes. So, as a matter of fact, I've actually talked on Newton's laws of motion. Yes, I've talked on Newton's laws of motion already. You don't have to be smart and not to waste time. It's just to send you the video. I've stated the 3 Newton's laws of motion and I've explained it in this class. Are we together? It's just for me to send you the what? The video. So that we can go to other topics and cover on time. So that we can go to other topics and cover on time. The only thing I will do about Newton's law of motion, I'll quickly talk about these two. These two guys are application of Newton's law of motion. The elevator lift system and the recoil speed of a gun. This will be my first 2 topics today. Because they are topics that I have not touched on, but they are under Newton's laws of motion. So this will be my first 2 topics, elevator lift system and recoil speed of a gun. But let us open the floor with these 3 hot motion questions. These are 3 hot motion questions. Are you done writing so that I can clean and start solving? Let me know in the comment section. If you are done writing, let me know in the comment section. If you are done writing, yes, Empress said I can hear you and I can see the board clearly. That's the energy. Someone said no leave, no transfer. That's the energy. Well done, class. Well done, class. Limadon said I can hear you, sir. That is the energy. Are you done writing? Can I start solving? Are you done writing? Can I clean and start solving? Let us go, let us go. Hope you have slept well. Hope you have slept well. Remember, I reminded you that we're going to start late today. I told you, right, that we're going to start late today, so go and rest. I told you earlier in the day that we're going to start late today, so take your time and rest. Hope you rested well. So nobody should sleep. If you're falling asleep, eat chewing gum, chew something, or clean your face with water. Let us go, let us go. So I'm assuming you've written the questions down. Let me start solving. Let me start solving. Let me start solving. Let me start solving. So class, like I said, we have already looked at these laws of motion, just that we'll look at these 2 applications under it. Class, a body moving with a velocity of 50 meters per second. Class means that the initial velocity of this body is 50 meters per second. Class, if I was to teach motion from the beginning, this is not where I'll start from. Why am I starting from here? Because I've already taught some things on motion, right? It's just for you to go and watch the video. Please take note. So someone that is just joining us today should not say, is this how they just start motion? No. There are some classes that I've held already. I'll send the link. Immediately after this live, I'll send the link. Please take note. So you can sit down and watch very well. But don't worry, the way I will solve this, you'll still catch up. Just follow me. Trust me on this. A body moving with a velocity of 50 meters per second means that the initial velocity of the body is already moving with 50. Class, U represents initial velocity 50. It's now brought to rest. Now, when you are brought to rest, means that the final velocity is 0 meters per second. Anytime you hear brought to rest in physics, it means that the final is 0 meters per second. V is 0 meters per second. And even they say starts from rest, it means that the initial U is 0 meters per second. But brought to rest means that V is 0 meters per. So by telling you if something is brought to rest, they are giving you the final velocity indirectly. And the time is 30 seconds. By a constant retarding force, calculate the distance covered by the body. Class, distance covered is S. S represents distance covered. In motion, we use S to represent distance. Class, when they give you a question of motion, the first question that should come to your mind, what equation of motion can correctly tackle this question? Every good physics student should already have the 4 equations of motion on their what? On the palm of their hand. V equals to U plus AT. V square equals to U square plus 2AS. S equals to UT plus half AT square. S equals to U plus V all over 2T. Class, the question remains, which of the following equation suits this question we have on the board? Class, you agree with me that is the 4th equation of motion. Because in the 4th equation of motion, we are looking for S. But we have U, 50. We have V, 0. And we have time, 30. So it's just for us to say that S equals to what? U, 50, plus V, 0, divided by 2 into bracket T. Who is T? 30. 50 plus 0 is 50. Into bracket 30. divided by 2. 50 times 30 looks like 1,500 divided by 2. 1,500 divided by 2 is 750 meters. 750 meters. Who got this before I got it? Sir, I got it before you got it. Sir, I got it before you got it. Who got this before I got it? Let me see. Let me see. Let me see. Who got this before I got it? Who got this before I got it? Good, good, good. Someone's already saying I'm enjoying the class. That's the energy. Someone already said I'm enjoying the class. We have not even gone far, but someone said I'm enjoying the class. Let's keep going. We are starting with a strong energy. We are starting with the right vibe today. Good. I will not live till the end. I will not live till the end. I will not live till the end. Yes, goodness says, I got it before you did, sir. That's the energy. That's the energy. That's good. That is good. That is good. I will not live till the end. I will not live. Omomi said, I will not live till the end. Good. Let's look at the second question, class. There's no time. Let's look at the second question. Please, if you are confused about the equation of motion, no need to panic. There's a video for you that I've taught from the beginning. I calmed down and taught it very well. No need to panic. I will just send it to you. Don't worry yourself. As long as you're on the physics registered group, I'll send it to you. Let's look at the second question, class. A car moving with a speed of 144 kilometers per hour. Class, a car is moving with a speed of 144 kilometers per hour. Class, when someone is moving already, it means that the initial speed is not zero. It's not. When they start the question, I say the car is moving. It means that initial speed or initial velocity is not zero because it's already moving. But if they say starts from rest, then the initial speed or the initial velocity is what? Zero. But in this case, it's already moving with 144 kilometers per hour. It then slows down with a uniform retardation. Class, retardation also means acceleration, but negative acceleration. Retardation means acceleration, but negative acceleration. That is deceleration of 10 meters per second square. How far will it travel? How far in physics means distance. When they say how far in physics, it's not written, it's not how far, it's say I did. No. How far means distance. How long means time. Are we together? Are we together? Class, how fast obviously means what? Speed, velocity, how fast. How far will it travel before it comes to rest? Coming to rest means that the final velocity is 0. So if U is 144, V is 0, and A is 10. How far S is what they asked us to find. Class, before we even think of the equation of motion to use, something is wrong. Class, in physics, one person is in kilometer per hour, one person is in meter. Class, you have to change this guy to meter per seconds. This guy is in kilometer per hour. You must convert your velocity to meter per seconds. How do you go from kilometer per hour to meter per seconds? Class, you have to multiply by 1,000 and divide by 3,600. Where is my calculator? You have to multiply by 1,000. So we're going to say 144 multiply by 1,000, then divide by 3,600. That will give you 40 meters per second. If you do everything very well, you have 40 meters per. So your initial velocity U has now been converted from kilometer per hour to meter per seconds. 40 meters per seconds. Class, had it been our acceleration was given in kilometer per hour square, then we would have left our initial velocity in kilometer per hour. For class, one person cannot be in meter per this, another person is in kilometer per this. Wrong. In physics, when solving, there must be uniformity. There must be uniformity. Now we cannot ask ourselves, what equation of motion will correctly give us our answer? Class, is clear that the second equation of motion will do that. Because based on the second equation of motion, we have that v square, which is 0 square, equals to u square, which is 40 square, plus 2, who is our a? Our a, class, is deceleration, so you put a negative. That's 2 times minus 10 times s. We are looking for s. 0 square is 0. 40 square is what? 1,600. 2 times minus 10 is minus 20s. Bring minus 20s over to this side, it changes to 20s without the minus. The minus sign disappears. We know that in mathematics, right? And when the sign moves over to the other side, it will change from negative to positive. So 20s equals to 1,600. We then divide both sides by 20. 20 cancels 20, so that 1,600 divided by 20 looks like 80 meters. Class, how far the body covered is 80 meters. Who got this? Sir, I got it before you got it. Sir, I got it before you got it. Let me see. Sir, I got it before you got it. Let me see. This is good. 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 I will not live till the end. I will not live till the end. Empress said, let's keep going, sir. That's the energy. That's good. Let's keep going, sir. That's the energy. I will not live till the end. This is good. Let's now look at the third question. Where's the third question? Yes. A body starts from rest, meaning that u is 0 meter per second. A body starts from rest and accelerates uniformly, class, at 5 meter per second square. Find the time taken. We don't know the time. To cover the distance means that s, they give us s this time around as 1 kilometer. They give us s as 1 kilometer. Class, something is already wrong. You must convert this 1 kilometer to meter. Because every other person is a meter, convert to meter. How do you go from kilometer to meter? Class, multiply by 1,000. 1 kilo is equivalent of 1,000 units. So that 1 times 1,000 is 1,000 meters. Now that we have our S, we have our A, and we have our U, we need only T. You are now going to ask yourself, what equation of motion should deal with this question? Class, the equation of motion you should choose is the one that has only one unknown. And I think the third one does it for us. S equals to ut plus half at squared. Our S is 1,000. Our U is 0. Our T, we don't know. Plus 1 over 2. Our A is 5. T squared. We don't know who is T. This is 1,000. 0 times T is 0. Plus 1 over 2, 5T squared. This 0 means nothing, so it can go. So I left with 1,000 equals to 5 times 1 is 5T squared over 2. Let us cross multiply. So that 5T squared equals to 1,000 times 2. We now divide both sides by 5. So that 1,000 times 2 gives us 2,000 divided by 5, giving us what? 400. So that T squared equals to 400. How do we make T straight to the formula? By finding the square root of both sides. Square root cancels square, so that square root of 400 is 20 seconds. Who got this before I got it? Sir, I got it before you got it. Let me see. Who got this before I got it? Let us go, let us go, let us go. Let us go, let us go, let us go. Someone said, I need all my secondary school fees back. This is so clear. So understandable. Thank you. Thank you. Someone said they made us think fees was hard. Time to go and collect my money from my physics teacher. Yes. Write down, let us now go to the elevator lift system and the recoil speed of a gun. Write down so that we can go to elevator lift system and recoil speed of a gun. Elevator lift system and recoil speed of a gun. Elevator lift system and recoil speed of a gun. While you're writing, let me be looking for questions down already. Elevator lift system and recoil speed of a gun. Elevator lift system, recoil speed of a gun. If you are done writing, say, I am done writing, sir. If you are done writing, say, I am done writing, sir. If you are done writing, say, sir, I am done. Okay. Binta said, I am done. Kelvin said, I am done. Good Lord said, I am done. Joshua said, I am done. So, let us go now. Class, and the Newton's 3 laws of motion, the first law is actually called the law of inertia. I've treated the law of motion in a previous video, but just to quickly recap, it's called the law of inertia. It's the first law of motion that says that a body will remain at rest, if at rest, or in motion, if in continuous uniform motion, except being distorted by an external force. And the second law of motion, so the first law of motion tells us that a body will be at rest except a force is applied. And it's one that produces formula F equals to ma. According to Newton's first law of motion, the force is directly proportional to acceleration. Force is the reason why there is acceleration. Without applied force, a body will not accelerate. What is acceleration? Increase in speed of velocity per unit time, right? Acceleration is increase in speed of velocity per unit time. So force is directly proportional to acceleration. The constant that comes in is the mass, m, so that F equals to ma. Class, this popular formula in physics was gotten from Newton's first law of motion. And the law of motion is known as law of inertia. What is inertia? Inertia is the resistance a body offers when they want to change the motion of a body, when you want to change the position of a body. There's a bit of resistance that the body will offer. That resistance is called inertia. Class, you want to lift a 100 kg object. You have to overcome the inertia of that object before you can lift the object. It won't go down easily, right? There's a bit of resistance you feel when you want to carry something up, right? That thing you feel when you carry something heavy up, that heaviness is the inertia of that body. Everybody has a level of inertia, a level of stubbornness, restriction. Don't carry me from here. You have to overcome the inertia of a body to move it from one position to another. And what do you use to overcome inertia? You apply force. Apply force. So class, inertia is the opposition or resistance a body offers to a change in its position or to a change in its state of motion. And inertia is dependent on mass of the body. The inertia of the body is dependent on what? On the mass. Dependent on the mass. Inertia of the body depends on the mass. Please take notes. The inertia of the body depends on the mass. Meaning that, what does that mean? A body that has a mass of 50 kg and a body that has a mass of 200 kg. Who do you expect to offer more position? Of course, it is going to be the 200 kg. So the more the mass of a body, the more the inertia of that body. The more the mass of a body, the more the inertia of that body. A body with a bigger mass will have more inertia than a body with a smaller mass. So inertia depends on mass. The second law of motion is known as the law of momentum. Why I'm not going deep is that there's already a video on it. There's a video on this. Now, class, the second law of motion tells us that the rate of change of momentum is directly proportional to the applied force and takes place in the same direction of the force. Class, the rate of change of momentum, that's why it's called law of momentum. Law of momentum. The rate of change of momentum is directly proportional to the applied force and takes place in the direction of the same force. Class, mathematically, Newton's law of motion is one that gave rise to this. F equals to mv minus mu all over t. Class, the symbol for momentum is P. And momentum means mass times velocity. We have two types of momentum. We have final momentum and we have initial momentum. So final momentum is mass times final velocity. Initial momentum is mass times initial velocity. Final momentum is mass times final velocity. Initial momentum is mass times initial velocity. Final momentum is mass times final velocity. So the formula for momentum is mass times velocity. Generally, if you ask for the formula for momentum, is mass times velocity. Now the final momentum is mass times final velocity. Initial momentum is mass times initial velocity. So class, if you ask to find change in momentum, because P is the symbol for momentum in physics, change in momentum will be equal to final momentum minus initial momentum, mv minus mu. That is, final momentum is mv minus initial momentum is mu. If ever you have to find change in momentum, is mv, final momentum, minus initial momentum. Class, it's easy to easily say that F is now equal to m into bracket v minus u all over t. Because this m can be what? Factorized. This guy has m, this guy has m. Bring out the m and you say v minus u is what's left. Class, if you now cross multiply here, f times t will give you ft equals to m into bracket v minus u. And guess what? What's ft? Impulse. Impulse equals to m into bracket v minus u. What does that tell us, class? That impulse is the same thing as change in momentum of a body. Note, impulse is the same as change in momentum of a body. Impulse is the same as change in momentum of a body. What does that mean, class? In the exam, you could be asked to calculate impulse. And many students already know impulse as force times time. So you are expecting them to give you force and time, but they are giving you mass, v, and u. You can use mv minus u to get impulse if you are not giving force and time. Yes, impulse is force times time, class. Correct. But if you are not giving force and time, impulse is also equal to what? Change in momentum, m into bracket v minus u. This was made possible from the Newton's second law of motion. This was made possible from the Newton's second law of motion. Class, we don't have more time. Let us move forward. Now to the third law. Class, the third law is the law of action and reaction. Action and what? And reaction. Hope nobody has left. I will not live to the end. I will not live to the end. Hope nobody has left. I will not live to the end. The third law is the law of action and reaction. This one, every physics student knows this law because it's too simple, right? Every physics student, even if you don't know physics, even art students, they know this law. Even those in commercial class, they know this law. Can we all state it together? Action and reaction are equal but opposite. Action and reaction are equal but opposite. I hope we are still there. I hope my network is still good. I hope you can see me clearly, you can hear me clearly, you can hear me, you can see the board clearly. Action and reaction are equal but opposite. Don't forget, if the class is too fast for you, if you have always had issues in physics and the class is too fast, you can rewind. Don't forget. You can even slow down the video for your own self. Don't forget that. Always remember this. Let's get the ball rolling. Let's get the ball rolling. Class, one of the major applications of Newton's law is the elevator lift system. Let us look at what happens in the elevator lift system. How many of you have been in an elevator before a lift? Have you noticed something when the lift is coming down and when the lift is going up? There's something you will notice. When the lift is coming down or when you're in an elevator and you're going down, do you notice that you are usually feeling lighter than your usual weight? But when you are going up, you feel heavier than your usual weight. Class, this is due to what we call the apparent weight in the lift system. This apparent weight is also called the false weight. It's called apparent weight or false weight. It's also called the tension in the lift. You can also call it tension in the lift system. You can also call it the tension in the lift system. Class, when you're in a lift elevator, the elevator must produce a force weight in order to take you up or to bring you down. Class, there is a formula T. This tension T is also known as the apparent weight or the force weight. Class, there is a formula for elevator lift system. M into bracket G plus or minus A. You could be asked to calculate the tension or the apparent weight in the lift system. This T represents tension or apparent weight or force weight. And the formula is T equals to M into bracket G plus or minus A. Why do we say plus or minus? I'll tell you when to use plus and when to use minus. Don't worry. Obviously, M represents the mass of the body in the lift. G represents the acceleration due to gravity. A represents the normal acceleration of the body. Class, so there's normal acceleration and there's acceleration due to gravity. This acceleration due to gravity is a constant. 10 meters per second square is a constant. But this A will be given to you. Class, when the lift is going up, we use T equals to M into bracket G plus A. When the lift is going down, we use T equals to M into bracket G minus A. When it is moving at constant speed or velocity, we use T equals to mg, class. No acceleration. Class, at constant speed or velocity, acceleration is 0. Class, when the body is moving at constant speed or velocity, there is 0 acceleration. So we use T equals to mg. Please take note. I hope you are still there. I hope we are still there. T equals to mg. Yes, they said, sir, we are here. We are here. Good. Let us take a question. An elevator of mass an elevator of mass (4,800 kg) is supported by a cable which can safely withstand a maximum tension of 60,000 Newton. Find the maximum upward acceleration Find the maximum upward acceleration. Class, by saying upward acceleration, they are simply telling us that the body is accelerating what? Upward. They are telling us that the elevator is moving upward. Class, when going upward, what formula should come to your mind? T equals to M into bracket G plus A. When going up, we use plus. When coming down, we use minus. Class, it's clear they're giving us our maximum tension at 60,000. T is 60,000. M is 4,800. Your G is, you don't need to be given, is a constant. G is a constant, class. Everybody knows even from secondary school that G is 10 meters per second square. So G is 10. It is A we are looking for. Say find the maximum upward acceleration. We are looking for A. Class, first things first, divide both sides by 4,800. So 4,800 cancels 4,800. We have 0, 0, cancel 0, 0. 600 divided by 48. We have 12.5 equals to 10 plus A. Let us bring 10 to this side. It becomes 12.5. When 10 moves to this side, it becomes minus 10 equals to A. So that A is 12.5 minus 10 is 2.5 meters per second square. Class, this is the maximum upward acceleration. If you see a question like this in Jamb, just blast it immediately. If you see a question like this in Jamb, just blast it immediately. Jamb is 1 month away. 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 An elevator of mass 4,800 kg. An elevator of mass 4,800 kg is supported by a cable which can safely withstand a maximum tension of 60,000 Newton. Find the maximum upward acceleration. Find the maximum upward acceleration. Class, because they said upward, it means that when the elevator is going up, what's the formula? T equals to M into bracket G plus A. Class, tension, you can see maximum tension of 60,000. So T is 60,000. Mass is 4,800. Class, nobody needs to give you G. G is a constant, 10 meters per second square. A is the person we are looking for. Find the maximum upward acceleration. We are looking for A. Do this and you get your A. Do this and you get your A. Quickly, so we'll take another question. Quickly, so we can take another question. Another question, let's go. An elevator is moving downwards with a 70 kg man. Find the net force and the man's apparent weights. If the acceleration of the lifts as the elevator moves down is 3 meters per second square. An elevator is moving downward with a 70 kg man. I hope you can still see the board. I hope we can still see the board. An elevator is moving downwards with a 70 kg man. Find the net force and the man's apparent weight if the acceleration of the lift as the elevator moves down is 3 meters per second square. Let's keep going, let's keep going, let's keep going. Let's keep going, let's keep going, let's keep going. Let's keep going, let's keep going, let's keep going. I will not live to the end. I will not live to the end. Let's keep going, let's keep going, let's keep going. Good. Kelvin said, I will not live to the end. Good, good, good. Let's keep going. An elevator is moving downwards. This time around is going down. With a 70 kg man, we have to find the net force and the man's apparent weight. Class, I was informing you, class, that in an elevator or a lift system, there are two key forces at play. Let us say this is the object in the elevator. This is the object in the elevator. It's going downward, right? This object has a weight called W. Don't forget that the weight of a body is also the force of gravity acting on that body. That's why you notice that weight, the unit for weight is Newton, because weight means force. The weight of a body means the force acting on that body, force of gravity, the natural force of gravity acting on the body. The weight on your body, is the natural force of gravity on you, is your weight. And class, there's also what we call the tension in the lift system, T. So there are two forces acting in a lift system. The tension of the apparent weight in the lift system and the weight of that is at play in the lift system, the object in the lift system. Now I want to tell you, this is how we should find the net force, class. The net force in a lift system, the formula, can change depending on whether the lift system is going down or going up. Class, when the lift system is coming down, please take note that the net force is the weight of the object in the lift system minus the tension in the lift system. This is when the lift is going down. But when the lift is going up, the net force is T minus W. This is what makes physics very difficult, class. The formulas keep changing. You know one formula, they bring another question. You know this formula, they now bring another question. There are always many ways of confusing you in a physics exam. It only takes a very well coached physics student to be able to tackle such challenges. It takes a well coached physics student to be able to tackle such challenges. There are always many ways your examiner can confuse you. So be very, very careful. This is why I said from now to Jamb, all our Jamb master students should do a year of Jamb pass question. Every day, 1 year of Jamb pass question must go down. By now, you should not open TikTok. If you have not opened TikTok today, let me know in the comment section. You have not opened TikTok today. You have not opened TikTok today. Let me know in the comment section. That's our students. They don't time delete TikTok. We are on Operation Delete TikTok. Operation Delete your TikTok. Operation Delete your Tik. This time to focus, to concentrate. To concentrate. You can say these things are very confusing. Some of you have poor foundations in secondary school, so you see that it takes a lot of time for you to understand these things. I'm trying to help, but you have to help yourself too. Delete all distractions. So class, you can see that they can confuse you. But let me tell you something, class. When the lift is moving at constant speed, then the net force in the lift system is 0. Please take notes. Why? Because, class, at constant speed, the tension in the lift system is equal to the weight of the body in the lift. Class, take notes. You could be asked a very wicked theoretical question in the exam. At what point is the tension in the lift equal to the weight of the body? At constant speed. Please take note. When the speed is constant, at constant speed. Good luck, Abunike said, I am feeling sleepy, but I won't live to the end. Good. At constant speed, the tension in the lift equals to W. So, class, they ask us to find the net force. Which of them are we going to use? We're going to use the first one because the lift is coming down. When the lift is coming down, it's W minus T. So we can claim the rest now. So, class, they also ask us to find the mass apparent weight. That means what's the apparent weight? Is T. T represents tension in the lift, also known as apparent weight. Class, what's tension in the lift when the lift is coming down? M into bracket G minus A. When the lift is coming down. What's M? 70 kg man. M is 70 kg. Your G is a constant, 10 meter per second square, 10. Minus your A, acceleration is 3 meter per second square, minus 3. This is 70. 10 minus 3 is 7. So 70 times 7 is 490 Newton. Class, this is the tension in the lift system. This is the mass apparent weight. We have answered the second part of the question. But the first part of the question, we find the net force. Class, the net force is going to be the weight of the man minus this tension we just got. Let us go and find the weight of this man. Class, do you remember that W, weight of the man, is mass times acceleration due to gravity G? Who remembers that W in physics equals to M times G? What is our M? The mass of the man is 70. What is our G? Our G is constant, right? 10 meter per second square. G is acceleration due to gravity. So that 70 times 10 gives us 700 Newton. So our W is 700 Newton. Our T is 490. So our net force is 700 minus 490. Therefore giving you 210 Newton, class. This is the net force in the elevator lift system. Who is still with me? Who is still with me? Who is still with me? I will not live till the end. I will not live till the end. I will not live till the end. Write down so we can go to recoil speed of a gun. Write down so we can go to recoil speed of a gun. I think everybody has the question now, so I can clean the question part. Please permit me to clean because we don't have time. Permit me to clean because we don't have time. Class, so elevator system has been done. Recoil speed of a gun. Class, this one application of Newton's laws of motion. Class, I won't waste much time here. I just need to explain to you that when a gun is shot, a bullet is fired, right? So there are two particles at play. We have the gun and we have the bullets. Now we have the mass of the gun mg, and we have the mass of the bullets mb. mg is the mass of the gun, mb is mass of the bullet. Class, are you aware that when you shoot a gun, for the bullet to go forward, the gun must experience a recoil backward. For the bullet to go forward, the gun must experience a recoil backward. Watch most of these American movies. When they are shooting in the movie, an action movie, notice that they vibrate backwards to show that they are intelligent actors, they are intelligent producers. But watch our Nigerian movies and they'll be shooting forward like this. They don't even apply the laws of physics in their acting. Class, there is no way you can shoot forward like this. Anytime anybody that holds a gun expresses a recoil. Same thing happens when you want to shoot an arrow, a catapult. The arrow or the quiver must first come back for you to push the arrow forward, right? There must always be a recoil before the forward movement. So the gun applies the same principle. So that's why we are looking at the recoil speed of a gun, because you'll be asked in the exam, at what speed does a bullet or gun recoil? At what speed does a gun recoil when a bullet is shot? Class, we also have what we call the velocity of the gun. In fact, we call it the recoil velocity of the gun because it's the gun that actually recoils. Recoil velocity of gun and velocity of bullets. So let this one be Vg for gun and let this be Vb for bullets. Vg for gun, Vb for bullets. So velocity of gun Vg, velocity of bullet Vb. Mass of gun mg, mass of bullet mb. Class, the formula will now come about. The mass of gun times velocity of gun equals to mass of bullet times velocity of bullet. Class, the negative sign here to represent the recoil of the gun. For the bullet to go forward, the gun must come backward. Who is still with me? Who is still with me? Who is still with me? For the bullet to go forward, the gun must come backwards. For the bullet to go forward, the gun must come backwards. Some people are laughing. Some students are laughing. Is it because of that Nollywood thing I said? Someone said formula is becoming much. Let us take questions. Let us take questions. A machine gun. Let's go. A machine gun. A machine gun with a mass of 5 kg. fires a 50-gram bullet. A machine gun with a mass of 5 kg fires a 50-gram bullet at a speed of 100 meters per second. Find the recoil speed of the machine gun. Find the recoil speed of the machine gun. A machine gun with a mass of 5 kg fires a 50-gram bullet at a speed of 100 meters per second. Find the recoil speed of the machine gun. Make sure you are not sleeping. I will not leave till the end. Make sure you are not sleeping. We just reached 1 hour of class, 62 minutes. Congratulations. Someone said, I understand this one now. Nancy said, I understand this one now. Good. This 62 minutes, 62 minutes. A machine gun with a mass of 5 kg. So the mass of the gun is 5 kg. Fires a bullet. Mass of the bullet. Let's put gun here. Let's put bullet here. Mass of bullet, MB, 50 gram. Class, gun is in kg, bullet is in gram. Something must give. Either you change this guy to gram or change this guy to kg. Let's change this guy to kg. 50 divided by 1000. Class, from grams to kilogram, divide by 1000. Please take notes. When you are going from grams to kilogram, divide by 1000. If you start solving like this, kilogram and gram, it shows that I am not an experienced physics student. Always convert your units to uniformity before you start solving. 50 divided by 1000 will give us 0.05 kilogram, kg. Having converted, class, bullet is moving at a speed of 100 meters per second. So velocity of bullet is 100 meters per. Find the recoil speed of the machine gun. So we are looking for the recoil speed of the machine gun. Velocity of gun is what we are looking for. Class, very easy. Mass of gun times velocity of gun equals to mass of bullet times velocity of bullet. The negative sign is here to show that there is a recoil. There is a what? A recoil. But let us solve without the negative sign. But the negative sign shows the recoil. Class, mass of gun is 5. Velocity of gun we don't know. Mass of bullet is 0.05. Velocity of bullet is 100. Let us make velocity of gun set of formula. Divide both sides by 5. So that 5 cancels 5. And we have velocity of gun equals to 0.05 times 100 is 1 to is 5. 5 divided by 5 is 1 meter per second. Class, the velocity of the gun is 1 meter per second. Who got it before I got it? Sir, I got it before you got it. Sir, I got it before you got it. I got it before you got it. I will not live till the end. 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 Who is still there? Who is still there? Others are sleeping. We are learning. Others are sleeping. The Jamb Master students are learning. Other Jamb students are sleeping. The Jamb Master students are learning. Someone say, I understand this one well now. Wow, interesting. Good. I got it. Yes, that's the energy. That is the energy. Yes. The good thing about it is that even the one you don't understand, you can always rewind and go and watch again, right? That's the advantage of online class. You can always rewind and go and watch again. That's the advantage of online class. Let's now go to momentum and collision. Let's go to momentum and collision. Let's go to momentum and collision. Class, my main focus is collision because I've talked about momentum before. We cannot talk about collision without talking about momentum. Class, what happens during collision is when two objects collide, class, there is always a change in the momentum of the objects. Class, a body that's moving with a speed of 5 meters per second. If another body comes and hits that body, it will no longer move with that speed of 5 meters per second. Its speed will change. And once a body speed has changed, its momentum has changed. Don't forget, that's why we say momentum and collision, because momentum is P, is mass times velocity. Momentum P, symbol for momentum, I told you about momentum P, is mass times velocity. So momentum is directly proportional to velocity. Once the velocity of the body has changed, momentum will change. So class, there are two, what causes a body's momentum to change if another body comes to collide with it? So the process of one body impacting another body is called collision. The impact a body has on another body after colliding with it is called collision. But we are not here for definitions, we are here for serious physics calculations. Class, follow me. There are actually 3 types of collision, but for physics level, we're going to teach you 2. We have what we call elastic collision and inelastic collision. Class, why do we divide collision into elastic and inelastic? Because elastic collision, after the two bodies collide, they go their separate ways. They don't stick together. The two colliding bodies don't stick together after collision. The two colliding bodies don't stick together. After collision. After what? Collision. Elastic collision is a collision in which the two colliding bodies do not stick together after collision. But for inelastic collision, class, the two colliding bodies stick together with what? A common velocity. Stick together after collision with a common velocity. The two colliding bodies stick together after collision with a common velocity. The two colliding bodies stick together after collision with a common velocity. I hope this is understandable, right, class? I hope this is understandable. Nicholas said, why didn't you make use of the minus in the recoil of the bullet, sir? We didn't use the minus because in our option there was no minus. The minus is just like almost like a positional sign to show the recoil. So that's why I first wrote it, then I cleaned it, show you that minus is recoil, but it's not every time you use it. Please take note. Class. Now write down law of conservation of linear momentum. 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 The law of conservation of linear momentum states that the total linear momentum of a system before and after collision is conserved. This implies that total momentum before collision is equal to total momentum after. Total momentum before collision is equal to total momentum after collision. Total momentum before collision is equal to total momentum after collision. Are we still together? Are we still together? Who is sleeping? 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 Who is that person sleeping? Who is sleeping? Wake up, wake up, wake up. Who is that person sleeping? Wake up, wake up, wake up. Class, we now need to look at different case scenarios. Class, let's look at case 1. Let us look at case 1. Class, let us say you have this body and this body. This is the first body and this is the second body. They were moving in the positive x direction before collision. This before collision. But after collision, they now stick together. So this body 1 and this body 2 with the same velocity called the common velocity. With the same velocity called the common velocity. So we have mass of this body is m1, mass of this body is m2. Class, initial velocity of this body is u1, initial velocity of the body is u2. According to the law of conservation of linear momentum, total momentum before collision equals total momentum after collision. The total momentum before collision, momentum here is mass times velocity. The formula for momentum is mass times velocity. The momentum of this first body is m1u1. Because this body is also moving in the positive x direction is plus m2u2. Class, this is one topic in physics that one formula does not fit all. The question determines what you do. That's why I'm telling you case 1. I'll show you case 2. This is case 1. Make sure you're writing fast. There's no time. This is a marathon class. m1u1 momentum plus m2u2. This was before collision. You see they are separate. They have not collided yet. But after they collided, it will now be equal to total momentum before. It must be equal to total momentum after. After collision, because they move with the same velocity, common velocity, it's now going to be equal to what? m1v plus m2v. Notice that the two masses have the same velocity because they stick together after collision. So the momentum of this first body is still m1 but v. This guy is m2 with what? V. So that's m1v plus m2v. Class, this now means that we have m1u1 plus m2u2 equals to what? Let us factorize v out. V is common here, V is common here. Bring V out. Into bracket what? M1 plus M2. Class, this is the formula that deals with this kind of scenario. As the scenario changes, the formula changes. This is why I chose this. This topic is super dangerous because You cannot just cram one formula. You can't just stand like forces, mass, and acceleration, and you're done. No. The scenarios, the circumstances involving the collision matters a lot. Let us look at case 2. Let us look at case 2. For case 2, this time class, and again you could be asked, what kind of collision is this? When the two bodies stick together after collision, we know that I told you now is what? Inelastic collision. When the two bodies stick together after collision, it's called what? Inelastic collision. Case 2. This is the first body moving like this, but the second body is now moving like this. So the first body is moving in the positive x direction, the second body is moving in negative x direction. If you draw your graph, class, from the middle like this is negative, from the middle like this is positive, right? So someone that's going like this is plus, someone that's coming like this is what? Minus. Then, but after collision, they stick together, no problem. The formula before collision will be mass of this is m1, u1, right? This m2, this u2. What is u1? The initial velocity of this body. Don't forget, before the bodies started colliding, before the two bodies collide, they had their different speeds they were moving at. The initial speed of this body is u1. The initial speed of this body is u2. Class, we use u for the speed before collision. That's initial. Once after collision, we don't longer call it u, we call it v. V is final. U is initial. This is going to be m1 u1. Instead of plus, we now have a minus. Why? But this guy is going negatively. Minus m2 u2 equals to what? If they stick together, class, always know that it ends like this. Equals to v into bracket m1 plus m2. If they stick together after collision. If they stick together after collision. If they stick together after collision. I will not live to the end. I will not live to the end. Let's look at case 3. This is body 1. And this is second body. Still opposite each other. M1 U1, M2 U2. But after collision, they go what? They are separate ways. They don't stick together. This is now elastic collision. It will be M1 U1 minus, but this is minus coming like this, right? This is plus going like this. So M1 U1 minus M2 U2 equals to, well, this is body 1, this is body 2. This is M1 V1. They will not have a different velocity because they don't stick together. Class, once two bodies do not stick together, they will not have the same velocity. They will have different. Notice when they stick together, they always have the same velocity V, common velocity V, right? When they stick together, they have the common velocity V. But when they don't stick together, class, they have their own separate velocity. So this is V1, this is V2. This is now going to be equal to M1 V1 plus M2 V2. M1 V1 plus M2 V2. Case 4. Case 4 is when one body is moving and this other body is at rest. So U is 0. This guy is at rest, at rest, at rest. You know you can be on your own and someone will come and jam you. God forbid bad thing. It's still collision class. So what happens when only one person is moving but one person was at rest? But after collision, two of them may now carry this one, they now start sticking together and move together. It's going to be m1u1 only. Class, once a body is at rest, it has no momentum, so we will not consider this body. Before collision, we will not consider this body because it's at rest. Only this body m1u1 equals to, after collision, they stick together, v into bracket m1 plus m2. This is the formula after collision. Let me go and check if you're still with me. Are you still there? Are you still there? Someone say, these formulas are many. That's physics for you. That's physics for you. That's physics for you. I will not live till the end. Class, note. Note, for elastic collision, the kinetic energy and linear momentum are conserved. You could be asked this in your theoretical exam. Kinetic energy and linear momentum are conserved. That is for elastic collision. For elastic collision. But for inelastic collision, kinetic energy is not conserved. Only linear momentum is conserved. Only linear momentum is conserved. Only linear momentum is conserved. I will not live till the end. That's the energy. I will not live till the end. That's the energy. Only linear momentum is conserved. Let's take our first question of the night. Let's take our first question of the night. A ball A of mass 5 kg moving with a velocity of 4 meters per second collides with another ball B, collides with another ball B of mass 10 kg moving with a velocity of 1 meter per second. in opposite direction. If A and B stick together, if A and B stick together, after collision, calculate their common velocity. Calculate their common velocity. If A and B stick together after collision, calculate their common velocity. Let us go, let us go. Victoria, well done. I will not live till the end. That's the spirit. Lima Dawn, I will not live till the end. That is the energy. That is the energy. I will not live till the end. I will not live till the end. I will not live till the end. Good, that's good. Who has gotten the question? Can I start solving? Who has gotten the question? Can I start solving? Who has gotten the question? Someone said the devil is a liar. Let us go, let us go, let us go. Let us go, let us go, let us go. A ball of mass 5 kg. Class, so our M1 is 5 kg, the first mass 5 kg. Moving with the velocity. U1 is 4 meters per second. Moving with the velocity of 4 meters per second. Collides. So it's one going forward first. So give him the benefit of the doubt and let him go in the positive direction. Collides with another ball B. So there's a second ball B. So let's call this ball A and this ball B. So mass of ball A should be MA. Initial velocity of ball A should be UA. Collides with another ball B of mass 10 kg. So mass of ball B is 10 kg. Mass of ball B is 10 kg. Moving with the velocity U is what? Velocity of B initial is 1 meter per second. For class, note, in opposite direction means that if A is coming like this, B is coming like this. And what did I tell you about someone coming like this? Negative. So A is going to have positive, B is going to have negative. But very important, after A and B collide, they stick together after collision. We all know what I told you. When they stick together after collision, what will happen? What will be the formula? So class, before collision, this is MA, UA, that mass of A, ball A times velocity of ball A. Now importantly, minus because it goes opposite direction. And if they say it went in the same direction as A, it will be plus. Take note, if B went in the same direction as A, it is plus. But in opposite direction, it's going to be minus. So MAUA minus MBUB equals to, now they stick together after collision. There's a common velocity V into bracket MA plus MB. I am just replicating exactly what I taught you in the examples. But this is a real question now. What's MA? Mass of ball A is 5. UA is 4. MB is 10, UB is 1. Equals to V into bracket MA is 5, MB is 10. 5 times 4 is 20, 10 times 1 is 10, equals to V into bracket 5 plus 10 is 15. 20 minus 10 is 10, equals to 15V. Divide both sides by 15 to make V straight of the formula. So V is 10 all over 15. 5 can go in 10, 2. 5 can go in 15, 3. 2 divided by 3, it looks like 0.667 approximately meter per. This is the common velocity. Who got this before I got it? Sir, I got it before you got it. Sir, I got it before you got it. Sir, I got it before you got it. Let me see, let me see, let me see. Sir, I got it before you got it. Sir, I got it before you got it. Let me see. Have you gone to sleep? Who is awake? Who is awake? Who is awake? No leave, no transfer. 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 Class, that is momentum and collision for you. It's now time to go to friction. Friction, friction, friction. Are you still there? We are covering our target one after the other. Are you still there? We are covering our target one after the other. Friction is the force that opposes motion between two surfaces in contact. Friction is the force that opposes motion between two surfaces in contact. Types of friction. Class, one thing you should know about friction is that it always opposes motion. If a body wants to go in this direction, friction won't take it in the other direction. Friction always opposes motion. Types of friction. We have one, static friction. This prevents motion from starting. We have two, sliding friction. This occurs when surfaces slide. Rolling friction. This occurs in rolling objects. Class, among the three types of friction, you could be asking is which of them is the least, has the least effect. The rolling friction has the least effect. Rolling friction has the least effect. Let's now go to laws of friction. Laws of friction. One, friction is proportional to the normal reaction force. Two, friction depends on the nature of the surfaces. Three, friction is independent of surface area. You could be asking me, which of is not true of friction? You should know what is true. Before you know the one that is not true, you should know the one that is true. What are the advantages of friction? Friction is one that enables walking. Friction also helps vehicles to move. Class, even this writing on the board is friction, allows writing. Disadvantages. Causes wear and tear. Produces heat. Friction also reduces machine efficiency, very important. Ways to reduce friction. Hope you have not left. I will not leave till the end. Don't forget the commitment. I will not leave till the end. Ways to reduce friction. One is by lubrication. Ball bearings. Polishing surfaces. Using wheels. Let me see if you are still there. I hope you are still there. We are 100 minutes in. 100 minutes. Congratulations. 100 minutes. I will not live to the end. 100 minutes of pure learning. 100 minutes of pure learning. 100 minutes, 100 minutes, 100 minutes. I will not live till the end. I will not live till the end. This is 100 minutes. I will not live till the end. Make sure you're writing. Make sure you're writing. Make sure you're writing. Let's now take a question. Where's friction? Let's take question. I will not live till the end. Class, look at the first law of friction. Friction is proportional to the normal reaction force. Class, we use frictional force. Let F represent frictional force. And class, let big Fn represent the normal reaction force. According to this law, the frictional force, which is small f, is directly proportional to the reaction force, big Fn. What is the reaction force, class? The reaction force is the force that acts upward from the ground against anybody under the surface of the earth. Class, as long as you are under the surface of the earth, you are standing on this ground, right? You are standing on this earth. There's a reaction force from the ground that acts upward, opposing your weight. In fact, the reaction force is super important because it supports the weight of any body on the surface of the earth. The reaction force is very important because it supports the weight of any object or mass under the surface of the earth. Follow me. Class, if an object is on the surface of the earth like this, the weight of the body acts downward, W, the weight, while the reaction force acts upward. The normal reaction force acts upward opposing to the weight. So it says Fn, you can call it Fn or Fr. The normal reaction force acts upward opposing the weight. So let's say this body is trying to move in this direction. The frictional force will come and oppose it in this direction, frictional force F. We are now being told that the law of friction tells that the frictional force is directly proportional to the what? Normal force. Because why is it directly proportional? Let me tell you something, class. The same thing this frictional force is trying to do, let us say you are applying a force F to this body. Let's say you apply a force F to this body and apply force F. The frictional force is always trying to oppose the direction of force on the linear plane, on the horizontal plane. Now let us say that this is the weight of a body acting, force acting downward. The normal force is also trying to oppose the weight of the body upward. So you can see why the frictional force and the normal force are directly proportional to each other. So the constant that comes in is what we call the coefficient of friction. And this coefficient of friction, we have two types. We have the coefficient of static friction when the body is static, and the coefficient of dynamic or kinetic friction. This coefficient of static friction and this is coefficient of dynamic or kinetic friction. Are we still there? Are we still there? It's getting hotter now. It is getting hotter. Who is still there? Who is sleeping? I will not live to the end. Who is sleeping? I will not live to the end. Who is sleeping? I will not live to the end. I will not live to the end. I will not live to the end. Let us now make coefficient of friction student for the formula. Your coefficient of friction will now be equal to what? F, frictional force, all over what? Reaction, normal reaction force. Small f, all over normal reaction force. Small f divided by normal reaction force. I will not live to the end. Let's take some questions. Let us take some questions on friction. Friction, where are you? Friction, where are you? Let's take some question on friction. Where's my friction? Don't waste my time. Come out, I must solve you. Where are you? Where are you? Where are you? Where are you? Friction. One, 4. Friction, where are you? Okay, write down. I hope you are still there. Nobody should sleep. Nobody should sleep. Nobody should sleep. A 20 kg block. A 20 kg block. A 20 kg block. Rest on a horizontal surface. A 20 kg block rests on horizontal surface. The coefficient of friction is 0.4. Calculate the frictional force acting on the block. Calculate the frictional force acting on the block. A 20 kg block rests on a horizontal surface. The coefficient of friction is 0.4. Calculate the frictional force acting on the block. We are told to take G. We are told to take G as 10 meter per second square. Class, don't forget that the frictional force we are looking for is equals to coefficient of friction times your reaction force, your normal reaction force. Sometimes we call it Fn, sometimes we call it Fr. They are the same thing. Reaction force, normal reaction force. Sometimes we call it Fn, sometimes we call it Fr. But class, I want you to know that your Fr, your reaction force, is your mass times acceleration due to gravity G. So that this is now equal to what? Coefficient of friction mg. So our frictional force F is what? Coefficient of friction times your mass times acceleration due to gravity. And what is the coefficient of friction? 0.4. What's your mass? 20 kg. What's your G? 10. 0.4 times 20 times 10 should give you 80 Newton. So our frictional force is 80 Newton. Our frictional force is 80 Newton. Another question. A 10 kg object is pulled along a horizontal surface with a force of 16 Newton. The coefficient of friction is 0.2. Calculate the acceleration of the object. Take G as 10 meter per second square. A 10 kg object is pulled along the horizontal surface with a force of 60 Newton. The coefficient of friction is 0.2. Calculate the acceleration of the object. I will not leave to the end, don't forget. I will not leave till the end, don't forget. Class, we have to find acceleration. If a 10 kg object is pulled along the horizontal surface, so mass is 10 kg. With a force of 60 Newton, applied force is 60 Newton. So if this is a 10 kg object, class, this is a force of 60 Newton that is trying to pull this body in this way. But class, note that the frictional force always acts in opposite direction to the applied force. Remember when I showed you those four forces? The frictional force always acts in opposite direction to the applied force. The weight of the body always acts downward. And the reaction force always acts upward. The coefficient of friction is 0.2. G, acceleration to gravity, is 10 meters per second square. We are asked to find the normal acceleration. Class, the applied force F is 60 Newton. If this 10 kg object to accelerate in this direction, it must overcome the frictional force that's pulling it in this direction. So we are going to say that the bigger force in physics is the bigger force minus the lesser force equals to mass times acceleration. The bigger force minus the lesser force, I mean the bigger force, that's the force that overcame, the overcoming force. This big force must overcome this frictional force for this object to accelerate in this direction. If they ask us to find the acceleration of the object, it means that the object moved in this direction. It accelerated in this direction. Therefore, the big force, the 60 Newton, overcame the frictional force. But we don't even know who is the frictional force. Let's go and find the frictional force first. Frictional force F equals to coefficient of friction times mass times acceleration due to gravity. What's our coefficient of friction? 0.2. What's our mass? 10. What's our G? 10. 0.2 times 10 is 2. 2 times 10 is 20. So we have 20 Newton. Our frictional force is 20 Newton. So class, in this side, there's a force of 20 Newton. Frictional force 20 is pulling this body in this direction. But the applied force is 60 Newton. With a force of 60. For there to be acceleration, we have 60 minus 40 equals to M, who is mass, 10 kg times A. 60 minus 40 is 20 equals to 10A. Divide both sides by 10. 20 divided by 10 is 2 meters per second square. In Jamb, you are allowed to slack small in one subject. At least in your Jamb, if you check anybody that scored very high in Jamb, you must at least hold 3 subjects very strong out of 4. Hold 3 very strong. Yes, every normal Jamb student, apart from the select few, have a little bit of weakness in one subject. So I can see that many of you are I'm sure you don't really like physics. So your English, pay attention to it. You should score at least 90, 80 something in your physics, in your English. Your chemistry, hold it tight. Your biology, if you're doing biology, if you're doing mathematics, hold it tight. So by the time physics comes in, you're still getting your 300. Are we together? Remember that 300 over 400 means that you have missed 100 marks and you still got 300. So for you to get 300, you still failed 100 because the total is over 400, right? You still failed 100, but you still got 300. Are we together? The person that got 300 did not get everything, he still failed 100. Are we together? So it's about being smart. Always recognize your strength and maximize it in your exam. That's what smart students do. Your English, when I was writing Jamb that year, I don't joke with my English, I don't joke with my physics. Yes, I love physics a lot. I love physics a lot. Chemistry. In fact, chemistry was one of my best subjects in Jamb. So find your strength, find your chemistry, physics, find your strength. Class, let us look at our next topic. Where are they? 37. Where are you? Have you gone to sleep? Have you gone to sleep? Have you gone to sleep? Oh, sorry class. My frictional force is 20. I shouldn't put 40 here, it should be 20. 60 minus 20 is actually 40. Someone just notified me on the comment section. That's very, very correct. Please. I made a mistake. And my frictional force is not 40, it's 20. Look at the 20. So it should be 60 minus 20. Giving me 40. 40 equals to 10A. Divide both sides by 10. So that my A is 40 divided by 10 is 4 meters per second square. My A is 4 meters per second square. My A is 4 meters per second square. Please take note of that. I don't know why I went down and put 40 here. 60 minus 20. Not 60 minus 40. My frictional force is 20, not 40. Let us go. Let us go. Let us go. Let us go. Where are you? Another question. A 5 kg block slides down a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction is 0.3. Find the frictional force. Are we still together? Are we still together? Are we still together? This is 122 minutes. That means we have spent 2 hours learning. We have spent 2 hours learning. 122 minutes. Well done, well done. Well done, well done, well done. This is good. This is good. Class, anytime you are told that a block slides down a plane at horizontal, find the frictional force. Class, frictional force we know is what? U class. But you are not going to say, it's going to be U mg cos theta. Anytime you are told that a block slides down a plane at an angle to the horizontal, F equals to coefficient of friction mg cos theta. And what's coefficient of friction? 0.3. What's our mass? 5. What's our g? Constant, 10 meters per second square, right? Acceleration to gravity. Cos, which is theta? 30 degrees. Where's our calculator? That will be 0.3 multiplied by 5 multiplied by 10 equals to 15 times cos 30 degrees. Cos 30 degrees is 0.866. If you do the math, you land at 12.99 Newton. Class, this is the frictional force. When we say it's inclined at a plane to the horizontal, 12.99 Newton. .99 is approximately 13 Newton. Some people are sleeping. Some people are sleeping. Some people are sleeping. Write down moments and principle of moments. Moments and principle of moments. We are almost there. We are almost there. Don't leave me. Don't leave me. We are almost there. We are almost there. Don't leave me. Don't leave me. Don't leave me. Where are you? Where are you? Class, one more thing on friction before I leave friction. Notes. One more thing on friction. When a body is just about to slide down an inclined plane, the coefficient of friction equals the tangent of the angle of the plane when a body is just about to slide down an inclined plane. The coefficient of friction equals the tangent of the angle of the plane. Class, and sometimes they have to find coefficient of friction. You just give it the angle. Coefficient is just equal to tan theta and you are done. Tan theta and you are done. Let's quickly look at a question quickly. Okay, I think I can just dictate this. A body is placed on a rough inclined plane. If you are told in the exam that a body is placed on a rough inclined plane, the body just begins to slide. When you hear that term, just begins to slide. When the plane makes an angle of 30 degrees with the horizontal, calculate the coefficient of friction between the surfaces. When it just begins to slide, calculate the coefficient of friction. That will be what? Tan 30 degrees. You get your answer. You get your answer. Please take note. Please take note. Please take notes. Are you still there? Who will stay to the end of this class? Who will stay to the end of this class? Who will stay to the end of this class? I'm saying Kelvin. I'm saying Caleb. Yes. Ifechukwu Faustina, Mary, well done. Some people have not slept. Some people have not left. Some people have not left. Some people have not left. Since the beginning, they have not left. Since the beginning, they have not left. Yes, yes, yes. Let's go to a new topic. 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 Equilibrium of forces. 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 Let's go. A body is in equilibrium when there's no net force acting on the body. When there's no net force acting on the body. A body is in equilibrium when there's no net force acting on the body in any direction. Class, we have to look at static and dynamic equilibrium. Now let me dictate so we can be fast. Note, when there is no net force acting on the body and the body is at rest, the body is said to be in static equilibrium. When there is no net force acting on the body and the body is at rest, the body is said to be in static equilibrium. When there is no net force acting on the body and the body is at rest, the body is said to be in what? Static equilibrium. But when there is no net force acting on the body and the body is moving with uniform velocity, when there is no net force acting on the body and the body is moving with uniform velocity. Now, what is uniform velocity? That's velocity that does not change. Consistent velocity, consistent speed. In a straight line, moving with uniform velocity in a straight line. Or is rotating. With uniform angular velocity, or is rotating with uniform angular velocity. About a fixed axis. Then the body is said to be in what? Dynamic equilibrium. Then the body is said to be in what? Dynamic equilibrium. Then the body is said to be in dynamic what? Equilibrium. Equilibrium. Class, there's one aspect I want to teach because Jamb will easily ask you this. Conditions of equilibrium. Of a body under the action of parallel coplanar forces. Make sure you are not sleeping. Make sure you are not sleeping. Where are you? We are just 33. People have slept. Oh, people have slept. Where are you? Where are you? Where are you? 33. From how many? Okay, in order not to make this video too long, we're going to stop here for today. Remember, as I told you for chemistry as well, these few extra topics are going to be taken in another video. So this video is not too long. Yes, because you have people that are going to school, people that are working. And this is already 12 midnight, it's understandable. So we'll stop here for today then. We'll stop the class here for today. But when next I'm teaching equilibrium, I will start from here and teach equilibrium and principle of moments. Principle of moments. So tomorrow is day 2, but please start getting used to serious work. Jamb is too close. Start getting used to serious work. You can see my eyes are wide open. You have to discipline yourself. You just have to discipline yourself. You're the one writing Jamb, I'm not writing Jamb. And I've been busy throughout the whole day, but I'm still awake. You have to discipline yourself. When you want to achieve success, you discipline yourself. So please learn to discipline yourself, guys. You're not paid for a class, you should discipline yourself. Tomorrow I'll be posting the link. I might start tomorrow's class earlier. If people do this night doesn't favor you guys, I might start in the tomorrow's class earlier. I'll let you know. I'll drop the link on the group. Let's continue tomorrow. If you stay to the end, say sir, I stay to the end. If you stay to the end, say sir, I stay to the end. Well done, class. If you stay to the end, say sir, I stay to the end. 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 Good. I stay to the end. Good. See you tomorrow. See you tomorrow. See you tomorrow. I stay to the end. You can go and sleep. Well done. Well done. Well done. You try. This 12 midnight. You are learning till 12. This 12 something. Yes. Over 140 minutes. Yes. I stay to the end. Well done, everybody. Well done, everybody. Well done, everybody. See you tomorrow. See you tomorrow. Let the video not be too long. I don't want the video to be too long. See you tomorrow. See you tomorrow. Well done, everybody. Good night.